So while we're waiting for the GC mass spec, second try on that Diels Alder product, we can be productive and run our IR spectrum. So I'm getting out the DCL 10-56R, the Diels Alder product. And I will obtain an IR kit. Try to get one that looks like it has been cleaned properly. So this one looks okay, I think. Kit number 5. It looks clean. We're going to put our collar on there. Look for a micro spatula. I've chosen the one that has the scoop end rather than the little V. And I probably need to re-angle my camera so it's pointing down a little bit more, so you can see what's happening down there. So we just want a little bit, very little. It's pretty light solid though, so volume-wise, maybe a little bit more than sometimes used. And as usual, we're going to grind that pretty thoroughly so that it smears all over the agate mortar and pestle. And it looks like it's not free-flowing anymore. I can tip it upside down, it doesn't come out, so we're good. And we'll grab some KBR. And I have no idea how dry this KBR is, or when the last time it was used was. So we're just going to hope for the best. Yeah, it looks like it's not too chunky. That's a good sign. There's one little chunk there. I kind of break that up. Now I'll take a scoopful of the KBR. Turn that. Wrench looks like it's in decent shape. So now we're just going to kind of grind that together. Use that as kind of a sandpaper to pull the compound off the walls and off the pestle itself. KBR was a little bit more granular than sometimes is, so I'm actually grinding as well as mixing here to try to get a really fine powder. It's pretty dry in the lab today, so today is a decent day for running KBR spectra. I'm not going to suck up too much atmospheric moisture. The snow is done. So that's pretty free-flowing. That should be a good pellet. Take about half of the material or so. Put that in there. And tap it to get it to cover the whole surface before we put our lid on it. Now it's a matter of getting that in without allowing the pieces to come apart. It looks like it's set about right. Yeah, maybe needs to be backed off a little bit. It's a lot of pressure. These little marks here should be a pretty good indicator, but maybe they're not. So I'll have to back that off a little bit more. In order to get that to click. And hopefully it's fused. We'll tap that on there to get that to come loose. I'm going to tighten it just a little bit and squeeze it again. I didn't have that much trouble squeezing it tight. Now let's see what we got. So we got a pellet, and holding that up to the light, it's fairly transparent, so that should be a good pellet. Maybe you can even see that. Wake a computer up here. Starting Windows. Very exciting. I'm going to set that down on its edge so that it won't roll while I check to make sure there's nothing in the sample chamber. And there isn't. Log in. Password chemistry 1114. We always get that, so we will ignore that message. Open up Omnic. Looks like we've got the IS5 standard experiment in there, default experiment file, so that's all set. We'll collect our background, making sure there's no sample in there. Standard background looks good. So now I'm going to collect my sample. And this is DCL-10-56R-3 because I took 2 GC mass specs. Okay, that, and then put the sample in when it tells us to. Okay, that. Just going to run 4 scans. And we've got what looks like a pretty good spectrum. It's almost 0% transmittance here in the middle at that big peak. But everything else is kind of on scale. And you'll see we've got a nice overtone peak here, which is the harmonic at twice the frequency of this very strong carbon-oxygen double bond stretch. So that looks pretty good. I'm going to save it. Into my folder. And we're going to set the file name to the title. We want to correct the baseline. It's a little bit slopey on that side, which is pretty normal for a KBR pellet. You'll notice that the baseline slopes more when we run a KBR pellet than it does when we run on sodium chloride plates. But you'll also notice that it's transparent all the way down to 400 rather than starting to absorb at 600 like the sodium chloride pellet does, or the sodium chloride plate rather. That's probably not baseline exactly. I'm just going to bring this one up. And I don't want to select these because it probably really doesn't, in this middle section, return to 0% transmittance. So that looks pretty good. We'll replace that. We got a nice flat baseline now. And I'm going to double click in here and add a comment that this is the Diels Alder product. Between 1,3-cyclohexadiene and N-phenylmaleimide. Let's label some peaks. We want that overtone band, so I'm going to select that. Well, you know, that's giving me a lot of peaks here though. So what I'm going to do is I'm going to select something in the middle so I don't see so many of these small peaks. And then I will label these, which I do want, individually. So we're going to call that good. We will change our display limits so that instead of starting at 37, we're going to start at 25, so that our peaks will be on scale. And we'll be able to actually see them all. And then by using the T here and holding down the Shift key, I can get it to choose the center of that peak. I may have to move this out of the way first. There we go. So I can hold the Shift key down and get it to choose the center of that peak at 3449, and then I want to label these two as well. You should know what those are. And then we'll just move these away so they're all kind of next to each other. 1705, 1770, that's an interesting peak. We've got a lot of peaks here that may or may not be something that we can interpret. That one at 1350 is just a small shoulder. I'm going to delete it. Same with this one at 1030 or at 1292. That's a tiny peak. So I'm going to delete that one. At 1301 is the top of that peak. 1326. So even though we might not be able to tell exactly why these peaks are there, that one's small enough that I'm going to delete it. Same with this one. We will be able to compare those to a literature spectrum and make sure that the literature has peaks in the same region. And that's why they call this the fingerprint region, because there are a lot of peaks that are very diagnostic. These peaks here are probably not significant. So that looks nice. Let's save that file. And then we will print this. Trying to avoid retyping things, but looks like I may have to retype it. It's really not worth doing a search, because the compound is almost certainly not in the library. let's just search anyway just to see what happens. Yep, 39.5% match to phenylbutazone in KBr. So not even worth printing those. There's nothing to be gained. But let's see what the spectral interpretation thinks we have in terms of functional groups. And the only functional group it's identifying is aliphatic hydrocarbons. And we got this big peak here and a couple of peaks there. So that's not very useful either. There's no point printing that. We're just going to be limited to using the numbers here and comparing them to literature to try to identify whether this is the right compound. I'm not going to save my changes. And I'll leave Omnic open because chances are we'll be running another spectrum soon. So just take the sample out of there. I have a melting point apparatus here because we are also going to want to measure some melting points on some compounds. Turn this. And now I need to clean that using one of these really stiff bristled brushes that will allow me to punch that pellet right out of there. And then clean with water to get the rest of it out. It's very important when you return these that you return them clean and dry. You don't want to put them back in that container if they're still wet. So the KBr was obviously pretty good, and that's not reaching in there very well, so we'll use a different brush for that, just to get the residual KBr out of the vessel. So a decent looking IR spectrum. There's clearly still the carbonyl in there, as you would expect from the maleimide. We can put that away and leave it until the next piece of data.